variables and operations. So operations are, we mean mathematical operations, so addition, subtraction, multiplication, division are our 4 basic ones, right? We've got some more, but those are the ones that we see most often. Expressions have a set value. Even if we don't know what it is. So what that means is just that an expression, like, I like to think of these like as different types of scales. So an expression is sort of like a bathroom scale, right? You stand on it, it tells you how much whatever you put on it weighs. And if you change anything about what you've put on the scale, it's going to change the numerical value of the weight, right? So the only thing we can do with expressions is rewrite them in a different way. We can't actually change them mathematically, otherwise we change their value, right? So we can't like multiply an expression by 2 without making it into a different expression with a different value. So the only things we can really do with expressions are we can simplify them, so rewrite them in a different way, or we can evaluate them. So when we evaluate, so for instance, 4x plus 5, if I wanted to evaluate this expression for x equals 1, I'm telling you the value of the variable and then asking you for the value of the expression. Whenever we evaluate, so whenever you replace a variable, put the replacement in parentheses. So this is true if we replace it with a number, replace it with another variable, replace it with a whole nother expression. Anytime you replace an x or a y or a z, you're going to put the replacement in parentheses. So in this case, we will write 4, replace that x with 1 in parentheses, and then plus 5. And some of this stuff, as far as notation goes, like I realize like this is a really simple problem. We probably could have just done this in our head. But what makes this class sort of unique is that the actual math that we do is probably all stuff that we recognize. But we're going to focus a lot on using formal mathematical notation, because as the math that you take gets more and more complex and you move into situations where the problems contain lots of different functions and lots of different variables, then it becomes really important that your notation properly labels everything. And so we're going to practice some of this, like some of these tools on problems that it might seem silly to do it on. Like it might seem silly to write this 4 times 1 plus 5, but we're building a set of tools and habits that's going to help us as we keep going into more complex problems. So I'm not doing it just for the sake of making you guys write more than you have to, I promise. We're just developing some good mathematical habits and good mathematical notation. So when I grade a problem like this, I always give it 2 points. The first point is given just for rewriting the expression exactly as it's written up here, but with the replacement value in parentheses. And then the second point is, I guess I should give you a point for the answer. So in contrast to expressions, equations are like the scales that you used like in high school science, right, where you put the cute little like weights on either side. These were like my favorite things in high school science, no? So these scales, they don't tell you anything about what anything weighs, right? They don't have numerical values for the weight of each side. The only thing they tell you is if the 2 sides have equal weight or if one side is heavier. And so that's what equations are like. I can make both sides 20 times heavier if I want to. As long as I've maintained the relationship between the 2 sides, it doesn't matter. So the numerical value of each side is less significant in equations. The equation itself doesn't have a value. All it does is tell us if the two sides are the same. In this case, they are the same because it's an equals. So equations look like an expression equals another expression. And our only concern with equations is maintaining that balance. So I can change the numerical value of either of these expressions all I want, as long as I change the other one in an equal way. So our goal with equations is often to find their solution. So a solution is any value for the variable which makes the equation true. So, for example, I could solve the equation 4x plus 5 equals 9. And notice that we already know the solution is 1. Because over here, we found that when we plug 1 into 4x plus 5, we get 9. So over here, it's really the same situation. But here, the unknown is the value of the expression, and I'm given the value of the variable. Whereas here, I'm given the value of the expression, and I'm asked for the value of the variable. So really, both of these problems are the same. It's just a matter of what the unknown is and what the known value is. And so here, I know what the solution is, but we'll go through how to solve it anyway. When we solve equations, we do so by undoing operations on the same side as the variable. So when we do operations, order of operations says we do multiplication, division first, addition, subtraction second. When we undo operations, we do it in the opposite order. So we're going to undo addition, subtraction first, and then undo multiplication and division. So I'll undo that addition of 5 by subtracting 5 from both sides of the equation. So subtracting 5 from the left side gives me 4x. Subtracting 5 from the right side gives me 4. And then I'm going to undo that multiplication by 4 by dividing both sides by 4. So 4x divided by 4 is just x, and 4 divided by 4 is 1. So you definitely don't have to write that down like the plus 5 or minus 5, but you should think through it. So a lot of times when people stop showing as many steps, they stop thinking through the steps, which isn't the intention of not showing them, right? So you don't want to, the biggest mistake people make when they start not doing things in their head or not writing something down is assuming it's going to give them what they want instead of making sure it actually gives them what they want. So that's why I go through 4x divided by 4 is x. So I'm verifying that it's actually giving me what I want instead of just assuming it. So you still want to think through each step, even though as these get more complex, you're going to find it nice not to write every single thing down every single time. So far, so good? It's hot in here, huh? Whew. Toasty. Okay, let's do a few examples of each of these. Whoa. Let's evaluate (4x) divided by 5y. 4x equals -10 and y equals 2. So again, just like that last one, we're going to replace each of our variables with the replacement values in parentheses. So we have 4 times -10 divided by 5 times 2. And go ahead and simplify that and then put it into your calculator. What do we get? What was that? -4. Did anybody put it in their calculator? What'd you get?
-4.
Did you put it in the calculator exactly as it's written?
Yeah, I did both multiplications first and then divided the two.
No, it's doing it in the order that you are supposed to. So order of operations says to do multiplication and division from left to right, right? So 4 times -10 is -40. -40 divided by 5 is -8, and -8 times 2 is -16. Yeah? So it is tempting. I mean, this one is intentionally tempting to like group things. And usually when people make mistakes with order of operations, it's because they're trying to do like 2 steps at once, right? Like I think if most people, if they did the first multiplication and then looked at it again, like would see the left to right thing, but it's just so tempting to try to do more than one thing at a time. And this is one of the things, like, I really believe that, like, we don't want to get tripped up on stuff like this, like on a test, especially when we're nervous. Your calculator knows order of operations. So if you type it in exactly the way you wrote it, like parentheses and all, it'll give you the right answer. It'll take care of all that stuff for you, and it doesn't get nervous on tests. So it's like, this is the type of thing you definitely want to use your calculator for, just so that you're not like making silly mistakes that, like, you know, as soon as all of you thought about it, like we all saw why this would be -16, right? So like, it's not like a knowledge thing. It's just like a going really fast thing. So on tests, just use your calculator for what it's good for, so you can focus on like the other stuff. Another one that like is similarly maybe misleading is like evaluate for x equals 4. So if we put just our replacement value in parentheses, what should I get, a positive or a -16 here? -16, right? Because that negative sign is like multiplying by -1. So this is really -1 times 4 squared, right? And if we look at it like that, we see that order of operations tells us to square the 4 first and then multiply by -1, which gives us -1 times 16, which is -16. This is different than if I was actually squaring the number -4, right? Where that -1 times 4 is inside the parentheses, so I'm doing that first and then multiplying the result by itself. So again, if you just put parentheses around just your replacement value and you put that in your calculator, I promise it'll tell you the right thing. Good? Let's solve some equations. We should do 2/5 x minus 1 equals 3/10 x plus 1/4. So every time we see an equation with fractions in it, the first thing we're going to do is clear fractions. So it's not that you have to clear fractions in every equation in order to solve them, but again, it's a tool that we want to learn, because when we have variables in the denominator, then we have to clear fractions to get them all up on the same level so we can solve for the variable. And really, if you haven't cleared fractions before and so this looks new and you kind of want to ignore it, I promise you, like if you do it a few times, you'll see it's like way more efficient and way quicker than doing all those calculations with fractions. Nobody really likes working with fractions, right? So we're just going to get rid of them in the very first step. And the way that we do that is that we multiply both sides of the equation by the LCM of all the denominators. So in this case, our denominators are 5, 10, and 4. So the least common multiple of 5, 10, and 4 is 20. So I'm going to multiply both sides of the equation by the number 20. So I'm not trying to make the denominator 20. I'm actually multiplying by 20 on both sides. So that means all 4 terms. So I've got 20 over 1 times 2/5 x minus 20 times 1 equals 20 over 1 times 3/10 x plus 20 over 1 times 1/4. And I'm allowed to do that because this is an equation, right? So I made each side 20 times bigger or 20 times heavier, but that's cool because I maintain the balance. And the reason that I chose 20, I mean, I could choose to multiply both sides of the equation by anything I want, as long as, like I said, I do it to both sides. But the reason I chose 20 is that it is divisible by all of my denominators. And so when I simplify this, we can think of factoring this 20 as 4 times 5, and the 5 cancels. And we're left with a factor of 4 on top times that 2x gives me 8x. Now the quick way to do that, so you don't have to write out the factorization, is that all we did here was divide 20 by our denominator, which gave us that factor of 4, which we multiplied by our numerator. So 20 divided by 5 is 4. 4 times 2x is 8x. So you can kind of do this in your head, but if you're not comfortable with that, that's fine. Just write out the factorization and cancel. So then minus 20 times 1, which is 20. And then over here we have 20 divided by 10, leaves us with a factor of 2 times 3x gives us 6x. And then 20 divided by 4 is 5 times factor of 1 is 5. So now we've gotten rid of all of our fractions, and now we just have to solve for x. So I'm going to subtract 6x from both sides of the equation. Subtracting 6x from the left side gives me 2x minus 20. Subtracting 6x from the right side gives me 5. And then we'll add 20 to both sides. So that gives me 2x on the left and 25 on the right. And then divide both sides by 2, which gives me x equals 25 halves. And we are going to leave it as a fraction. So a good general rule is that your answer should not be a decimal unless there are decimals in the original problem. And then we don't write this as a mixed number because they're actually not super useful in math. The reason that improper fractions are called improper is that they're improper English. So like we don't go to the hardware store and ask for like 25 halves feet of rope, right? Like we say, can I have 12 and a half feet of rope? Like that's how we talk. But in math, if we wrote this as 12 and a half, we would have to turn it back into 25 halves in order to do anything productive with it. So we're just going to leave it as a fraction. Unless it's an application problem and we're writing a sentence in English, in which case we'll write it in proper English. In my math lab, underneath the blank where you enter your answer, there are always instructions about how to answer. So it'll say like, enter all numbers as integers or fractions. And that's how you know it should be a fraction or a decimal or whatever it wants from you. It's really frustrating to have the right answer and enter it in the wrong form. So always read those instructions under the answer blank so that you know exactly what the program's expecting. Because it's only programmed to accept what it's expecting, right? Like it's not a person who can be like, oh yeah, that's the same. So far, so good? Questions? Okay, let's do another one. This will be the last one for today. Let's solve, where is it? There it is. 2 times 9 minus 3 times negative 2x minus 4. So whenever you're solving an equation, we see there's no fractions here, so we don't have to clear fractions. We always want to simplify each side of the equation completely by distributing to get rid of parentheses and combining like terms. That way we're not trying to solve an equation with like too much going on. So you want to simplify each side on its own first before you start doing things on both sides. So when there's multiple sets of parentheses, we always start inside out. So I'm going to distribute that -3 first, because that's the innermost set of parentheses. And we're distributing the negative along with the 3, so this becomes a positive 6x and a positive 12. And then I'm going to combine like terms inside the brackets because, again, we want to simplify things as much as we can before doing more operations. So before distributing that 2, I'm going to combine like terms. I get 21 plus 6x. And then I'll distribute, and I get 42 plus 12. Whoa. Oh my gosh, I did exactly what I always tell you guys not to do. Just ignored the other side. Plus 42. There we go. 12x equals 12x plus 42. And hopefully at this point we can see that both sides are the same, yeah? And so that means that no matter what number I put in for x, it's going to be, the two sides are going to be equal. If you didn't see that, you could be like, oh, I have to subtract 12x from both sides, and we get 42 equals 42. And hopefully at that point we would see that that's always going to be true, right? And so if that last step is always true, then the original equation is always true. And so our solution set is all real numbers, which just means that I can pick any number, plug it in for x, and it's going to make that equation true. Now, if instead of a 42 here, I was like solving that equation, we would end up with that, which is never true, right? Which means that no matter what I put in for x, there's no way I can make this equation true. So there's not any number that I can plug in for x to make the equation true, which would mean there was no solution. So it's sort of a similar situation, but that last line is either always going to be true or never going to be true, which will tell you if there's no solution or if the solution is all real numbers. The other option, of course, is that we get x equals a number, and then that's our solution. But in terms of these ones where the variables end up canceling each other out, you're either going to have no solution or all numbers will be solutions. Good? Okay, so your homework for tonight is to read the syllabus, register for my math lab. Remember, even if you can't buy the access right now, you can get that temporary access for 2 weeks. So everybody should do their homework tonight. You have my math lab homework, so you find that in online homework, and then you also have that written homework that you'll turn in to me tomorrow. If you have any questions at all about anything, feel free to text me through Remind, or my cell phone number is at the top of the syllabus. You can use that as well. My office is right down the hall in Hamilton 201. Feel free to come by and see me. And I will see you guys tomorrow. It was great to meet all of you.